So there's one last sort of piece of math that's crucially important for us to add in before we really start worrying about digging into the physics, and that's what happens when we multiply vectors with scalars. So let's take an example. So let's take vector A here, which happens to have a x component of 3 newtons and a y component of negative 4 newtons. So it's down here in the fourth quadrant. And then if what I'm interested in is, let's say, negative A, well, you can notice that what this is it's taking the vector A and multiplying it by negative 1. So here's my scalar. So what I've got is the vector A multiplied by a scalar. In this case, that scalar happens to be negative 1. Well, the x component of negative A is going to be negative times the 3 newtons, which is negative 3 newtons. The y component of negative A is going to be negative times negative 4 newtons, which gives me positive 4 newtons. So you notice that vector A points down here in the fourth quadrant, but minus A actually points up here in the second. So they point in opposite directions. Now you'll also notice, because we'll come back to this, the magnitude of vector A happens to be Pythagorized with our components here. 3 squared plus negative 4 squared, take the square root. The magnitude of this vector, vector A, happens to be 5 newtons. But the same is true for the magnitude of vector negative A. So here are two vectors that have exactly the same magnitude but point in opposite directions. So what we do then is we're going to take, to get the components of negative A, we're going to take the components of A and simply multiply each of them by negative 1. Again, same example, let's try a different scalar. So here, 2A, which basically means our scalar now is positive 2 that we're multiplying times the vector A. So when I take the x component of A and multiply it by positive 2, I get 6 newtons. When I take the y component of vector A and multiply it by 2, I get negative 8 newtons. So here what happens is positive 6, positive x component, negative 8, negative y component. I still have a vector that points in the fourth quadrant, and in fact it points in the same direction as vector A. It just happens to be twice as long. So vector A has a magnitude of 5 newtons. 2A has a magnitude of 10 newtons. And again, what I see is that I multiply both components by plus 2 to get the new components of my vector. One last example. So again, same vector A, but now what I'm going to do is I'm going to take vector A and multiply it by negative 1/2. So my scalar here is negative 1/2. So again, when I go ahead and calculate my new x component, I'm going to get negative 1/2 times 3, so this is negative 1.5 newtons. I'm going to get negative 1/2 times negative 4, this is 2 newtons. So my new vector here, which is negative 1/2 A, again points in the opposite direction, and now what you see is its magnitude is half the magnitude of A. 3 squared plus negative 4 squared, take the square root, that's 5. Negative 1.5 squared plus 2 squared, take the square root, that's 2.5. So my magnitude has been cut in half and my vector's flipped around. And again, what you see is you multiply both to get the new components. You're going to multiply both components of vector A times negative 1/2. So just sort of generalizing out from our 3 examples here. So there's a couple things that hopefully a couple patterns you sort of started to see. So what happens when you multiply any vector with any scalar? So C here is our scalar that we're going to multiply by some vector A to get a new vector B. Well, the first question to ask is the scalar positive or negative? And this is going to give us information about direction. So if our scalar is positive, then A and B are going to point in the same direction. So this was the case where we were multiplying by positive 2, and we said positive 2A pointed in the same direction as A. If, on the other hand, the scalar is negative, then A and B point in opposite directions. So both of our other two examples, both where our scalar was -1 and where our scalar was -1/2, we said that the resulting vector flipped around and pointed in the opposite direction as A. It was up in the second quadrant rather than pointing down in the fourth. So thinking about the sign of our scalar gives us information about direction. The other question that we can ask is, well, how does the absolute value of the scalar compare to 1? And this is going to give us information about magnitude. So if the absolute value of our scalar is greater than 1, then the magnitude of vector B will be greater than the magnitude of vector A. So the one example we saw was for our scalar of +2. The magnitude of that is 2, and sure enough, the magnitude of 2A was twice as long as the magnitude of A. If, on the other hand, the absolute value of our scalar is less than 1, then the magnitude of vector B is going to be less than the magnitude of vector A. So this was a situation where we had our scalar was -1/2. So again, the negative sign doesn't matter here because we're just taking the absolute value. But what we found out was that the magnitude of 1/2 A is less than A. It's actually half of the magnitude of A. Well, the third option, the only thing left is if your scalar happens to be 1 or -1, then the magnitude of B is going to be the same as the magnitude of A. So our first example where we looked at -A, because you're really multiplying by a scalar of -1, and -1 has an absolute value equal to 1, the magnitude of -A is the same as A. They just happen to point in opposite directions. So these are the rules for what we're going to get when we multiply vectors by scalars. So just making sure that we understand these is going to be helpful for us in terms of explaining vector subtraction and then helping thinking about the direction of vectors as we go forward. So that's why this is important stuff to understand.